Good morning. Pressure is the last process variable that we are going to discuss in Chem Tech 1. By definition, pressure is the ratio of a force to the surface area. It's the amount of force exerted on a surface area. Different units can be used. You are familiar with those units. This includes Newton per meter squared, which is equivalent to Pascal. You have the second unit in American engineering unit, pound force per inch squared. You must be familiar with the abbreviation PSI or psi, which stands for pound per square inch. ATM for atmosphere and millimeter of mercury, as well as tertiary. There are different devices that can be used to measure pressure. Please advise you to go through our recommended textbook to have an idea on those pressure sensing devices, which include uh, mercury manometer, capacitive sensor, strain gauge, and so on. Moving on to the next slide, there are different type of pressures. In fact, 5 types of pressures. These are the atmospheric pressure, that is the pressure of the air and the atmosphere which is surrounding us. Air is exerting a certain force on everything on Earth. Now that force divided by the surface area leads to atmospheric pressure. Now atmospheric pressure is not constant, it changes from time to time depending on temperature and so on. Now, in calculations, we assume that atmospheric pressure is equal to 100 kPa or 1 atmosphere. But uh, the truth of the matter is that it changes. It changes uh, depending on atmospheric conditions. We are most of the time having values here in Durban between 95 kPa and maybe 110 kPa. By barometric pressure, number 2, we mean atmospheric pressure. So it is the same as atmospheric pressure. I'm used to ask students during test, what is the difference between atmospheric pressure and barometric pressure? The answer is they are the same. It's like the same bottle, but with different labels. Number 3, absolute pressure. By absolute pressure, we mean the pressure which is measured with respect to complete vacuum, with respect to zero pressure. When the reference pressure is 0 kPa or 0 Pa or 0 psi, then the value of pressure that you have with respect to 0 is called absolute pressure, whereas gauge pressure is the pressure that you measure upward from atmospheric pressure. So when you use as a reference, as starting point for your measurement, the atmospheric pressure, then you measure what we call gauge pressure. Now you can convert from gauge pressure to absolute pressure using that equation. And vacuum pressure is the pressure measured downward from atmospheric pressure. Now, this here, it's important that you are able to convert the height of a liquid column into pressure. For that one, you use this formula. Pressure is equal to density of the fluid times g, which is the acceleration due to gravity, times the head, which is the height. We are going to solve some problems to illustrate that one. Now, a manometer is a device that it's used to measure pressure. Now, you have different type of manometer, and here we present a manometer consisting of a U-shaped tube, and it uses a liquid. When the liquid is pushed as the effect of pressure, it allows you to measure the difference of pressure between the two sides of your U-tube, taking into account or using the difference in distances. We have an open end manometer, which can be used to measure the pressure at a certain point. Like, for example, we have here a pipe with a liquid or a gas flowing. Now, to find out the pressure at this point, P1, assuming that it's open here, we have the atmospheric pressure. You just have to use the formula. Pressure is equal to uh, the pressure here is equal to that pressure plus density times g times h, which is the distance. So when you have one end which is open, you are going to measure the gauge pressure here. When you have the two branches directly connected to the tube like this, the difference of height in the two branches will give you the difference in pressure. We say that this is a differential manometer, and you are going to find the difference between pressure 1 and pressure 2. And when, for example, you have a sealed end, like here, it means that you have vacuumed one side and you have closed that side properly. The pressure is 0. The difference of height is measuring the absolute pressure here. So let us recap. If one end of your manometer is open, it means that the difference of height here is a measure the the gauge pressure here. When that end is sealed at 0 kPa, then the difference of height here gives you the absolute pressure. And when you have the two ends open, connected to the pipe, then you have the differential pressure. So that ends our discussion on pressure. We are going to have exercise. Bye.